Have you ever stopped to wonder how your phone, your laptop, and your smart TV all talk to each other so perfectly? It's not magic, it's architecture. Today, we're going to pull back the curtain and look at the invisible blueprints that make our entire digital world possible. So let's dive right in.
Seriously, just think about it for a second. Right now, in your home or office, you've got a whole network of gadgets. Your phone, your computer, maybe a smart speaker, a printer, they're all chatting away. But how? What's the hidden plan that lets them all work together without getting their wires crossed? Well, that's exactly what we're about to unpack. The secret sauce here is something called network topology. And honestly, the best way to wrap your head around it is to think of it just like an architectural blueprint for a building. It is the master plan that lays out exactly how every single device is connected and, crucially, how information flows between all of them. Okay, so here's our game plan. We're going to take a quick tour of these digital blueprints. First, we'll look at some of the foundational designs. Then we'll check out the model you probably have at home, the hub and spoke. After that, we'll get into the really complex stuff, this web of connections. And finally, we'll figure out how you choose the right plan for the right job. All right, our tour starts with the basics, two of the most fundamental layouts in the history of networking, the bus and the ring. Think of these as the simple OG answers to a really complex problem. So, first stop on our tour is the bus topology. Now, this is one of the simplest, oldest ways people figured out how to link a bunch of computers together. And this is a fantastic way to picture it. Imagine a single main street. All the houses are the computers, and they all have a driveway connecting to that one road. Data is like a car that has to drive up and down that single street to make its deliveries. It's super simple, right? But you can probably already see the huge glaring problem. If there's a pothole or a break in that cable, the entire street shuts down. No traffic gets through. And yeah, that's the trade-off, isn't it? On the one hand, a bus network is super simple in shape to set up because you don't need much cable. But the downsides, they're massive. Having a single break in the line take down everything, well, that's a critical vulnerability. And as you add more and more devices, you get traffic jams. So you can see why this design is pretty much a museum piece today. So to try and solve some of the bus's problems, especially all that data crashing into each other on that one road, engineers went back to the drawing board. Let's check out what they came up with. The ring topology. So instead of one long road that just ends, the ring connects the ends together to make a circle. The best analogy is a traffic roundabout or maybe a circular subway line. Data gets on and travels in only one direction, stopping at each station or device until it reaches its final destination. Pretty orderly, right? The big win here is that the one-way traffic flow means no more data collisions, which was a real headache on a busy bus network. But it has its own fatal flaw. In a ring, if just one single device goes down, the whole circle is broken. The entire network is kaput. This fragility meant that, just like the bus, it wasn't really reliable enough for the modern world. These early designs and their very obvious flaws really paved the way for something much, much better. And that brings us to the undisputed champion of modern local networks, the star topology. And this is absolutely the key takeaway here. If you've got a Wi-Fi network at home or you're connecting to one at the office, you are almost certainly using a star topology. It's the king because it solved that big reliability problem right when personal computers started showing up everywhere, each needing its own stable connection. This visual nails it. Think of a bicycle wheel. Right in the middle, you've got the hub. That's your Wi-Fi router. And each of your devices, your laptop, your phone, your tablet, is like a spoke with its own direct line to that central hub. Now here's the beautiful part. If one spoke breaks, the rest of the wheel is fine. The other devices keep on working. But this also shows you its Achilles heel. If that central hub fails, the whole network is dead in the water. So when you weigh the pros and cons, the benefits are just so clear. It's a breeze to manage, and one person's computer crashing won't cause a company-wide panic. Yeah, it's totally dependent on that central hub, but for most of us at home or in the office, where you can just reboot or replace the router, it is a trade-off that is absolutely worth making. But what if a single point of failure just isn't an option? What if you're building something mission critical, like the backbone of the internet or an air traffic control system? For that, you need something with way more resilience. And that's where we get into the really cool stuff, the web of connections with mesh and hybrid topologies. So let's start with the heavyweight champion of reliability, the most fault-tolerant blueprint you can get, the MASH topology. This is the design for networks that absolutely, positively cannot go down. Ever. The easiest way to get this is to picture a dense city street grid. Instead of one main road or one central hub, you've got a ton of interconnected streets. Every intersection is a device, and it's connected to several others. So if one road is blocked for construction, your data just says, no problem, and instantly finds another way to get where it's going. This built-in redundancy is what makes it so incredibly reliable. It literally heals itself. So what's the catch? Well, its greatest strength is also its biggest challenge. The upside is unmatched reliability. There is no single point of failure. But the downside? Just look at all those connections. It's incredibly complex and expensive to set up and manage, needing a ton of cable and some really smart routing to make it all work. Of course, in the real world, not every problem fits neatly into one box. Often, the smartest solution is to mix and match, to combine different designs to get the best of all worlds. And that's exactly what the hybrid topology is all about. And this is a perfect real-world example. Imagine a big office. You give the marketing department its own robust star network, so they're all self-contained. You do the same for the accounting team. Then you connect both of those star networks to a simple cheap bus network that runs down the main hallway like a backbone. And voila! You've just created a star-bus hybrid, using the strengths of both blueprints to make a custom, efficient solution. So, we've gone through all these different blueprints. The big question is, how do you actually choose the right one? Well, it all comes down to balancing three key things: performance, reliability, and, of course, maintenance. This table really sums it all up perfectly. You can see the trade-offs at a glance. The bus, low on cost, but also low on pretty much everything else. The Star strikes that sweet spot, high performance and easy maintenance, which is why it's perfect for most of us. And the Mesh, it's the peak of reliability, but you're going to pay for it in complexity and cost. And that right there is the single most important thing to remember. There is no single best network topology. It's like building a house. An architect wouldn't use a skyscraper blueprint for a garden shed. A network architect picks the plan that best fits the specific needs of the job, balancing cost, performance, and how badly things will go if it breaks. Which leaves us with a really interesting thought to chew on. As our world gets more and more connected, with everything from our cars to our coffee makers coming online, with things like satellite internet and 6G on the horizon, what will the network